Perfect. Morning, everybody. So I'm Kieron Salter. I'm the founder of KDB Special Projects and Digital Manufacturing Centre, which is currently being built up at Silverstone. KDB Special Projects has been in business now since 2012, and we came out of primarily a motorsport environment, motorsport background as engineers, and started transferring that technology to other sectors, including aerospace, automotive, marine, medical, etc. But one of the things that we've been involved in a lot of is additive and digital manufacturing. So that led to the formation of the DMC, which I'll tell you a bit more about, as a real world example of a digital manufacturing center, which hopefully does everything it says on the tin and is really digital from end to end. So the DMC is being currently built up at Silverstone. It's a 20,000 square foot facility. We expect it to be open and operational in April this year. It's a project that's been going on for some time now. The original idea of spinning out our additive manufacturing technology into a new business was nearly 4 years ago now. That concept was dreamed of, and we started looking for funding and methods to do that, and we wanted to do it at scale. We didn't want to just do a small scale linear expansion of where we currently were. And so we needed some funding, and we were very fortunate to find some funding through SEMLEP, our local enterprise partnership, to accelerate and kickstart this project, and providing a reasonable amount of the funding towards our 10 million costs that are going to be expended on this facility as a whole. But it's, as I say, a digital manufacturing centre from end to end, very much focused on additive manufacturing as a process, and I'll explain some of that reasons for that in a minute. But our sectors, which we expect to be able to service, are going to be the obvious ones from motorsport that we're already involved with, but also aerospace, defence, medical, industrial, and land transport. And if we reflect this back onto the sort of title at the beginning of impact of COVID and digitization, as I said, this project was already in process when COVID came along, and we had to really think and address whether it was still the right thing to do, because we were at a point back in March where we could have perhaps paused it or even aborted it completely. But the main problems for us, we felt, were that two of the major sectors that we were going to address, aerospace, commercial aerospace and automotive, were two of the sectors to be quite hard hit by the economic downturn of COVID. So we spent a lot of time deliberating and strategizing about what the right thing to do was, and actually we came to the conclusion that the rapid adoption of digitization was probably going to be in our favor, and we could see that happening literally by the week as COVID progressed. And we also felt that digitization and advanced manufacturing technologies were going to be the recovery of these sectors, and actually were going to be even more important than perhaps they had been just months before. So we decided it was time to push on and continue with the project, but make some changes as well. And some of those changes have been how we use the office space, how we use the facility, how we control people through that facility, and make sure everyone's safe. And change, the way in which we use the office and communicate to people has changed. So we've been able to bake some of those things into our facilities as we go along in terms of some of the changes that we've implemented. One of the key parts to the Digital Manufacturing Centre, as I mentioned earlier, was additive. And being an additive manufacturing process, I'll just lead you through how AM workflow is. And it lends itself to digital. In fact, it more than lends itself to digital. It is digital from the outset. And we have to have a digital asset in order to manufacture something in an additive manufacturing or digital manufacturing process. And that digital asset is normally a CAD model. And very often nowadays, the CAD model is generated from the original conception of the idea and the design process. But actually, if it's an archive part or a legacy part, we can also scan data and bring that in and create a digital asset. But we have to have a digital asset in order to manufacture a part with additive. So once we've got the CAD model, that digital asset can be used for a number of things. It can be used for simulation. It can be used for finite element analysis. It can be used for production analysis. It can also be used for marketing and website purposes. So there's a whole range of things that digital asset drive. In the manufacturing process, we use that asset to go through the build and then the final machining and inspection. And that's a typical linear process for additive manufacturing as we've known it for a few years now. But to make it really valuable, we need to connect it all as a closed loop and connect the end of the process right back to the beginning of the process and ensure that we're getting the learning from inspection. So we can manufacture parts, we can inspect them, and now we can understand at the end of the process any variances, any differences that are happening during the manufacturing process through wear, tear, or manufacturing tolerances. And we can feed that information back into the digital asset, and we can learn from that and actually improve the process. But it's important that everything's connected to do that. And at a machine level, that's it's all possible now. And you'll see that we have a Renishaw machine there. Renishaw are one of our collaborators for the Digital Manufacturing Centre, and we will have a full suite of Renishaw AM equipment and inspection equipment to enable to get this full connectivity. So this is what our facility looks like on the inside at Silverstone. It's can possibly be a lights out, or is a lights out facility. We can run this operation without many staff. It's automated machinery, but you can see we've got a range of the Renishaw machines in the middle of additive for metals, but we also have polymer and SLA, which are our other technologies that we already have within our current KWSP facilities are also going to move to Silverstone. And all of that will be connected and integrated so that we've got full data control through those manufacturing processes. So virtually, this is what we think the facility will look like if you could see that connectivity. Every machine connected back to the production process. But it's actually important to understand that there's not one system that really can sort of have a control of all these things. There's layers of connectivity that we'll have at Silverstone, and I'll talk you through some of those. So at the first level, there's the engineering level, which is the CAD data, which is created by the engineers in a variety of CAD systems and from our customers. That data is then fed through to the production systems, and the production systems are both engineering in terms of data control into the machines, and for the CNC machining and inspection, but also the production system for job tracking and job management, which are the things that Dolores was talking about. And then, of course, there's another level that we can think about, which is the building itself, and making that smart and making sure that we understand how that environment is managed efficiently, how the energy is controlled, and also how that environment has an impact on our manufacturing process. So I mentioned that we've started with the Renishaw machines. So I'm going to use this to just explain at the very first level, the machine connectivity. So an additive manufacturing machine now is basically this particular example is a powder bed. So you have a powder of metal, and that metal powder is then sintered using a laser. So it's essentially welding the powder to create a homogeneous metal part out of the raw materials, using only what you need. So it's completely opposite of CNC machining, which is subtractive, where you take a billet and you machine away material. This, we start with a powder and build the part up. It does still need final machining, and that's a process that we will have at Silverstone so that you can do some of the important finishes for tolerancing at the end. But this machine being driven by CAD data means that we're also measuring and monitoring all the parameters in that machine, and we're able to connect this machine back to the CAD process and to the inspection process. So within the Renishaw central server and central connect system, we're able to collect the data, analyze the data. It gives us performance data for the machine, so we understand productivity, machine job tracking, and also then the parameters and all the important manufacturing data that we can associate and assign to each individual part and keep for traceability, which is important for quality standards, in particular when you're starting to look at aerospace type components. But having all that data, you have to be able to store it centrally, you have to be able to manage it and use that data for something useful. And in the case of the Renishaw Connect, we're using it to drive not only the manufacturing, but our inspection and joining those processes up, as I showed you on the previous slide, so that we're able to get learning and feedback. But there's also the important productivity bit that comes out of it as well. But the machines that don't have connectivity, we're able to still monitor using IoT devices. So we can actually measure the power consumptions, the productivity, the machine utilization by by discretely measuring each machine and feeding that data back in to the overarching system. And we're going to be doing that with Beckhoff, and Beckhoff are going to be helping us create a network within the manufacturing plant that allows us to monitor not just the machines that are already come with connectivity, but machines that we need to add connectivity to. I mentioned the building because it's often overlooked, but we have an opportunity with a brand new building as well to ensure that we're using smart building control systems. And so it's more data that we can use to create a more energy efficient and smart building, but also access control. So we're able to use it for the comfort and control of the facility for the users, but also we're able to then collect that data and use that data as an overlay onto our manufacturing process. So for example, we could be manufacturing a component in an additive manufacturing machine that experiences a fault at the end of the process in inspection, and we're able to identify that fault when we do the inspection process, but we're not able to understand why that fault occurred. We'd be able to overlay and look at all the data, not just for the machine and the machine parameters and how it's operating, but the data for the facility. So maybe the HVAC systems weren't functioning properly in a lights out situation, and maybe there was a temperature spike, either hot or cold within the facility, or maybe there was a power surge. Maybe the machine itself had an error. We're able to time track and timestamp all of that data. We'll be able to track back and understand not only that there is a fault with the part when we inspect it, but how that fault occurred, and therefore make improvements to fix it, and to understand really what the fault conditions were, which is really important. And it's only a benefit that you can achieve if you're able to collect the data. So it's worth mentioning that this is only possible at Silverstone, not only because of the SEMLET funding and KWSP's vision and funding into the project, but also the fact that we're building relationships with partners. We're having partnerships with machine providers, but also our CNC machine services. So we're building a CNC facility here, which actually is a collaboration with a company called Progimax, because they're able to bring with them their explicit knowledge about CNC machining, which we don't have. And we're also building partnerships with other additive manufacturing processes. So we're creating a true digital hub of additive manufacturing and digital manufacturing process at Silverstone. And we're open to any offers and ideas about how we can improve that, how we can demonstrate new technologies, and how we can be an advantage, not just to small businesses, but to education and young people that want to see engineering as an opportunity to come and work. So I believe, if I got this right, the next slide is a little video which will give you a sense of the excitement and some of the technologies that we're putting into the DMC, and hopefully gets everyone inspired for what the Silverstone project will deliver. Thank you. That's the end of my introduction to the DMC. I'll just leave with this very kind note from Lord Sugar, who suggested the Digital Manufacturing Centre is really the future. Thank you.
Great, Kieron. Thanks very much. When's your first rocket getting built?
We've already started.
That's setting the bar high. Has Lord Sugar been to visit you?
He hasn't, no, not yet.
I think I'll throw it straight over to Jolie. Have you? What did you make of that?
Is my screen still sharing, by the way?
Yeah.
It is.
Yeah. Can you hear us, Jolie? You might have frozen on my screen. Dolores, what did you think to that?
I think it's really exciting. And well, you know, it hit all my points around the collaboration and the importance of being able to actually see things. I mean, there's been so much theoretical conversation about the smart factories and the advances, and what I really see that Kieron and his team have done is they've gone, let's actually show you this at work, and they've looked at every detail from the building to the door entry to everything all the way through, and how can they apply that digitization. Yeah, I'm looking forward to being able to actually come visit and see what's going on.
I think the really important bit, if anyone's thinking about doing something similar to this, is you've got to get the infrastructure right. If you get the infrastructure right in terms of the hardware, the software bit will be an ever-changing beast, and you can layer the software in quite easy. That's the benefit of software. You can make big changes without having to make big changes to the hardware.
Yeah, absolutely. A machine is still a machine. Still has to be somewhere that makes sense.
I mean, one of the challenges that we're finding actually is that I mentioned there that there are several layers to the digitization. You know, you've got building control, you've got machine control, you've got engineering, and you've also got manufacturing, and you've got finance, and you've got production, and actually getting those all stitched together is the trick. And there's not, if anyone's looking for one piece of software or one supplier such as SAP to solve all your problems, it doesn't work. You need to tailor it, and actually in the current environment of software, discrete bits of software are relatively cheap to achieve, and you can build something customized.
Yeah, I agree.
Was being based at Silverstone key for you, Kieron, and building those relationships, that one of those last slides that you mentioned there? Well,
it's always, I mean, Silverstone's a very familiar place for me, and you know, it's been my stomping ground since I graduated and started working in motorsport. So it wasn't key from a motorsport point of view. I would say that it was certainly an accelerator for the project, simply because of the involvement of SEMLEP and the fact it's an enterprise zone, which has made it commercially less risky and a bit more viable. You know, these projects aren't cheap, and you know, we need a leg up, and we need some help with as small businesses. It's the small businesses that are ambitious and innovative. The one thing that we tend to be short of is cash, but you know, we genuinely believe that we can deliver back the things that the local community needs. So jobs, education. We are attracting companies to Silverstone that wouldn't have thought to go there before, like Produmax. So sowing that seed, SEMLEP sowing that seed at Silverstone with us has definitely already started to work, and we expect it to continue to do so in that respect.
Of the motorsport organisations, there, are they already talking to you about using your facility?
Yeah. I mean, we already have most of the F1 teams as customers within our current. So the current additive manufacturing facility within KWSP will be spinning out as this new facility at Silverstone. So that will take with it the customers that it already has. But yeah, we have already a good customer base, and that's building. And the fact that we have that extra capacity and space at Silverstone is of great interest to some local teams.
Yeah. In terms of the skill sets, then, in terms of when you're hiring there, is it a very specialist skill set, digital manufacturing, or is there a split of, you know, digital skills for certain jobs, manufacturing for other jobs?
It is. I mean, it is, but it isn't. You know, the whole sort of job description in engineering has changed quite a bit recently. I mean, not recently, over the last few years. I remember when I graduated as a mechanical engineer, it was a mechanical engineer and an electrical engineer. They were the two courses that you did, and you didn't have much crossover. You know, we now employ engineers that need to be able to do software controls, electrical and mechanical. And actually, they're coming out of university with all of those things. There's a lot more electrical and integration into mechanical engineering these days. You know, in terms of the skill sets for Silverstone, it's everything from digital workflow through engineering, design, through technicians to operate machines. If you've got the right aptitude, everything's trainable. we expect to offer that sort of training and on-the-job training. But it's nothing special. What we always need is people that are interested. That's the special bit. That's the bit you can't teach.
Is it possibilities or opportunities there in terms of building relationships with, say, a digital academy at Northampton College, University of Northampton, link ups there into their courses, or maybe influencing the kind of courses that they're teaching?
Yeah, we're very open to that. We've already started some of the dialogue with the UTC, for example, that's just across the road from us from school age, and also Milton Keynes College and others. So yeah, we want to build those networks and create a useful facility to engage with young people to have otherwise, that's our future employees, isn't it?
Yeah, great. Jolene, I think you're back with us.
I had just dropped out there, so apologies. So I might be saying what you've already said, but love the video, absolutely love it at the end. And in terms of the exciting, inspiring, and it's really interesting. I know that you were just talking there about the skill set and engineers. So for us in Northamptonshire, it's certainly an area where recruitment is difficult. And kind of, we've talked about a number of different forums and involving kind of the youth at an age where we can influence and actually demonstrate how exciting the engineering manufacturing world can be. And as I'm kind of watching and listening to you, I think it absolutely has that kind of pull and kind of the draw too. So it looks really exciting.
For me, there's two areas of focus in terms of that skills piece. And the first is, which is I believe is the most important, is you've got to inspire people at a young age. So at school age, you've got to inspire them to have some ideas about what it is they might want to do. And we want to change the perception of engineering and make people realise that engineering is cool, it's exciting, it's not all your rags and climbing under a car. It's software, it's control, it's electronics, it's advanced manufacturing, and also working in cool sectors. We have a bit of a mantra, which is we'll do anything as long as it's cool. We don't want to do normal. So we want to be building bits for rockets, bits for defence, bits for space, bits for automotive, motorsport, medical, life sciences, solving really, really challenging problems. And if we can show young people that those are the opportunities, if you can work in those sectors, and all you need to do to be able to do those cool jobs is you need to have some engineering skills to get you into that facility. That's the first bit. So we intend to have a rocket lab actually at Silverstone, which will be a little R&D centre where we'll build small rocket engines for demonstrations and get children involved with what we're doing there and understanding how they all work. We're working with a guy that's developed this jetpack that you've probably seen on the news, which they're using for rescue operations. That's going to be some involvement with that at Silverstone. But then once you've got young people inspired, the next bit is to then offer them the opportunities to get work experience. And so at college and university level, we want to be able to offer work placements, industrial placements, so that people can actually then understand which element of the engineering they want to get involved in and what training they then need to get to deliver that.
With the interest you might get, Kieron, you might need to build a school outreach section in that new factory. I think it's people as well at high profile with Elon Musk and the space program that he's got. It's a lot more, it feels a lot closer rather than it just being something far away at NASA or something like that. It does feel like it's a lot closer and more touchable for people these days.
Yeah,
accessible. Yeah, absolutely. Great. Really appreciate that, Kieron. Fantastic presentation. Lots of people want to connect. I mean, I would suggest I can...
LinkedIn.
Yeah, LinkedIn's probably the best way. If you just search people's names on LinkedIn, that's the best way to do it. Great. Thanks very much. I'll stop the recording there.